morning, ladies and gentlemen.
Good morning.
Today, you are about to embark on a journey that I hope you will not soon forget. Well, today, we will travel to the world of circuitry, and I need three things from you. Number one, I need your undivided attention at all times. Number two, I need your scientific imaginations. And number three, I need your hypothesis. What's a hypothesis? Yes?
It's an educated guess.
You are absolutely correct. A hypothesis is an educated guess. But what's an educated guess? And don't say hypothesis and try to trick me. What do you think?
An estimate.
It's close, close. Yes.
Your important guess.
Close. Yes.
Johnson. Guess.
Okay. One more.
The best guess that you could possibly.
The best guess that you could possibly get. Well, a hypothesis is an educated guess, but an educated guess is simply a guess based on what you already know. For example, if I were to reach here and pull this quarter from behind your ear, and I hold this quarter between my fingers, what is your hypothesis? What do you think is going to happen if I were to part my fingers? Think of everything possible. Yes.
It falls.
It'll fall. What else? Yes.
Drop.
It'll drop. That means fall. Yes. What do you think?
It'll drop on the desk.
On the desk. Think of everything. Will it?
It'll drop. It'll drop because of how gravity pulls items.
Okay. What else would it do other than fall, other than drop? Yes.
I think when it falls, it will hit the battery and make a sound.
It may hit the battery, make a sound. Yeah.
It might fall and make a sound.
Make a sound. Okay. Let's one more.
It might hit the chair and make a fight.
May hit. Let's find out. Wow. It fell. It hit the table. It bounced. It spun. It rolled. And it made a noise, and it landed on heads, didn't it? Lucky for me. If it had landed on tails, I would have had to give each of you one. Now, what we're going to do today is we're going to take a quick field trip. I have a bus parked outside. Don't worry about getting permission slip signed. I talked to your parents last night, and they said you could ride with me. Don't worry about getting a good seat on the bus because they're all good seats. I have little bitty seats for little bitty people. Great big seats for great big people, and they're all comfortable seats. We're going to a place called Circuit Boulevard, and on Circuit Boulevard is my laboratory. Once we arrive at my laboratory, I will invite you in, and you will become my junior scientist for today. Now, I expect high things from my junior scientists. Number one, the junior scientists always stay on task. You can't get in front of me, you can't get in back of me, you got to stay with me. Now, if we get into my laboratory and I see you touching stuff when you're not supposed to be touching stuff, if I see light bulbs coming on, I'm going to simply point to you and say, you are now an observer. And in my laboratory, an observer don't touch anything. They sit and watch everybody else. So if you can agree to those terms, let's get on the bus. You agree?
Yeah.
You sure?
Yeah.
Okay, let's go get on the bus. Thank you for using your scientific imaginations. We're almost there. We're turning left on Circuit Boulevard now. We're here. Watch your step as you get off the bus. I wouldn't want you to fall and skin your pretty little knee. You're now in my laboratory. You're all my junior scientists. The very first thing I want you to do is take a careful look around. Now, if you noticed, I've made my laboratory look exactly like your classroom. I had to do that for a reason. It's because it's against the law for me to scare little children. Or if you were to really see what's in my laboratory, it would scare your socks off, because right over here, there's an 8-foot tall clear capsule, and inside that capsule is a 7-foot tall man, floating in a liquid called formaldehyde. Do you know what formaldehyde is? That's a liquid used to preserve dead people. He's been floating since 1895. We like to call him Herman. And you, don't make any sudden moves, because right behind you, there's a 17-foot crocodile. He hasn't eaten in 2 weeks. And if you were to make any sudden moves, He just might gulp you up. And I must ask everyone, do not look up. Please do not look up. For on the ceiling there are hundreds of bleeding eyeballs, and if some of the blood were to touch you in your face, it would freeze you through eternity. Welcome to my laboratory. And since you are in my laboratory, located on Circuit Boulevard, it's only fitting and fair that we talk about circuits. Today we're going to build 3 different circuits. I'm going to give you the definition of those circuits, and by the time you leave, you'll know the difference in all 3 circuits. But before we can talk about any circuit in the entire universe, you have to understand, before a circuit can really become a circuit, it has to have these 4 things. Somebody name one. Yes?
It has to have an energy.
Energy source. You are absolutely correct. Correct. Got to have a power source. Wherever your energy comes from, that's your source. What else does it need?
It probably have a switch.
Switch, yeah, but in order for it to be a circuit, it doesn't have to have a switch, and it doesn't have to have an insulator, even though those things are good. Okay, what do you think?
A magnet?
No, don't have to have a magnet.
Wires.
Wires. Let's call the wires something else. The wires would be anything electricity can travel through. So what are we going to call them? That's a conductor, the wires, yes.
Cable.
All right, let me use your scientific imaginations. You're in the forest, and you see the tall trees, and you see the bushes, and you can hear the leaves crumple beneath your feet as you walk. And there, in a short distance in front of you, is a trail, a way out. What's another word for that way out? Yes, a path. So all the wires and all of the, whatever electricity travels through, the conductors, it's a path, okay? Now, wherever your energy comes from is your what?
Source.
Huh? Wherever your energy comes from is your
Source.
Whatever energy travels through is your
Path.
So what else do we need? What would you call like a, what do you think we need now?
Load.
You're absolutely, you get a Dr. Shock high five for that. A load. A load. What is a load? Yes.
Like a battery or something.
No, that would be your source.
Oh.
The battery. That's where your energy comes from. What's a load?
An example is like a light bulb.
You're exactly right. A light bulb, a computer, a PlayStation, whatever electricity goes through and makes work is a load. That would be a TV, a microwave, whatever. Now this last one you probably don't know, so let me use your scientific imaginations. If I go out the door there, down the hallway, back to the parking lot, and I stop and turn around, and I come back down the hallway, all the way back into this classroom, what is my coming back called? It's my...
It's where it's sort of like you're retracing.
You're close. It's re-something. I have just...
Return.
There you go. Return. So, any circuit, help me out, in the entire universe has to have a...
Source.
Help me.
Load. Return.
Very, very good. Now, that's something else that I do in this classroom. I kind of draw on the board. Anyone caught laughing at my drawings because I'm not a good artist? I come to your house and I eat your little puppy. And if you don't have a puppy, I'll give you one, take him back, and then eat him. I love Chihuahua. Now, what do you think this is? Tell me. Yes.
Battery.
No.
Outlet.
No.
Traffic light?
No.
It's one of those things that's on your wall.
No.
An electrical outlet?
No. Think about it. Think about it. Yes.
Plug-ins.
It's a source.
Yeah, baby! It's a source. Remember what I said? Wherever you get your energy from is your power
Source.
All right, now if that's a source, then what would you call this? Yes?
A path?
You're half right. And the reason I say you're half right is, you ever notice on a regular extension cord it's got that line right down the middle? Well, if you were to take a very sharp object and go down the middle of that, it'd actually be two separate wires. And one of those wires would be your path. What would that other wire be? Return, right. What are we missing? What are we missing? We got our source, we got our path, we got our return.
The load.
We're missing a load. Let's make this our load. I know no one's laughing at my drawings. That's your load. Yeah, it's an old TV. Now, and it's playing my favorite TV show, Stick People. Now, here's what happens. When you plug your path into your source, the electricity goes down the path on that one wire. Then it goes into your load. It makes your load work. Then it comes out of your load on the return wire all the way back to the source, and then it goes to the ground. That's the electrical symbol for ground. Make sense?
Yes.
Now, if you're with me, say, I'm with you, Doc.
I'm with you, Doc.
If you're ready to rock, say, let's rock, shout.
Let's rock, shout.
Now, if you really didn't quite understand and you want for me to repeat all this again, say, do it for me. Do it for you? Okay, I'll go back and do it for you. When you plug your path into your source, the electricity comes down that one wire into your load, makes your load work, then it comes out of your load, back on the return wire, back to the source, and then to the ground. Make sense now?
Yes.
All right, if you're ready to rock, say, let's rock, shout.
Let's rock, shout.
All right, here's how the instructions go today. I'll give you instructions, and then I'll say, please do so now. If I don't say, please do so now, then don't touch my stuff. Deal? Yeah. Okay. In front of you is a big battery. That battery is only 6 volts, a 6-volt battery. When I ask you to do so, I want you to unscrew the battery cap. Some of them don't have caps, but if your battery has a cap, you want to unscrew the cap and put it on the table. Get your hands off my stuff. I didn't say please do so now. Please do so now. Also in front of you is a plastic bag. Inside that plastic bag is 1 circuit board, 2 wires, and 3 light bulbs. When I ask you to do so, I want you to take all the items out of the plastic bag. You want to put your circuit board in front of you long ways, not sideways, but long ways. Once you put your circuit board down, you want to take your 2 wires and put them to one side, take your 3 light bulbs and put them to the other side. Please do so now. All right, everybody got 1 circuit board?
Yes.
Everybody got 2 wires?
Yes.
Everybody got 3 light bulbs?
Yes.
Everybody got everything separated?
Yes.
So if you're ready to rock, say let's rock, shop.
Let's rock, shout.
All right, if you need some time because you're slightly behind, say, hey, wait for me. All right, everybody's on task. Good. Now, I'm going to name some things that you'll be working with, and that way when we talk about them later, you'll know exactly what I'm talking about. All right? You see these 2 little gold things on top of your battery?
Yeah.
Look like little springs? They're called battery terminals. Okay? If you notice, if you look right on top of your battery, one of those terminals have a plus sign and the other one has a minus sign. Now just for the record, the plus sign is positive and that's our path. The minus sign or negative is our return. Right, okay? Now, do you see these little black and red things on your circuit board? We're going to call those wire screws. The things that the wire screws are holding down, we're going to call those wire arms. When I ask you to do so, I want you to remove or unscrew to the left all of your wire screws and then remove your wire arms. I want you to make your board look like my board on the board. Anybody bored? Okay, if you need some help, please let me know. Please do so now. Want to make your board look like my board. Some of those may be a little tight, and I'll help you if you need me. Work with your board long ways, okay? Work your board the wrong way, sweetie. Like that. Yeah. There you go. Good. Good. It's too hard? Why didn't you let me know, man? You know I'm here for you. You didn't have breakfast this morning, did you? That's why you're not strong. Yes. Okay. You're good. You got him. If you're with me, say I'm with you, Doc. If you're ready to rock, say let's rock, Shock. If you need some time, cause you're slightly behind, say, hey, wait for me.
Hey, wait for me.
You're on a fast. Uh-oh. There are some people here ready to rock. Take your other side off there. Right here. All those come off too. Come on, man. Hurry up, man. You're trying to make everybody miss the bus. You're ready to rock with Dr. Shock. This table is ready to rock. This table is ready to rock. Whoa! What table is not ready to rock? Raise your hand. Okay. What you waiting on, Junebug? You need some help? It's too tight? Is it too tight? You sure? God, that one is tight, man. All right. Now, in any scientific experiment, you have to inspect all of your equipment before you can proceed. Because if you don't check your equipment, you may have a faulty reading. So starting now, through middle school, through high school, through college, and in some of your professional careers, you have to inspect your equipment. Let me give you an example. If I was looking through a microscope right now at a piece of cotton, and my microscope lens was dirty, I would make a note that looks like this. Cotton is brown in color. Would that be true? No. I need to clean my lens. So we got to check all of our equipment. First thing I want you to check, let me borrow your board. When I say please do so now, I want you to go down and wiggle each one of these screws, not yet, and make sure that they're tight. Okay? If you find one loose, let's say this one here is loose, I want you to put your finger behind it so it can't turn. Then you come back on the front side and tighten up that little wire nut screw there. Okay? Please check your circuit boards now. If you have one loose and you can't tighten, let me know. I'll be glad to help you. I'll take all these off.
Oh, I got two.
You got two? I believe you loosened one of them just so I can come over here and give you some special help, didn't you?
No.
Where's the other one? This one? Okay. I think that'll get it. Anybody else? Got one? Which one? Okay. You got one too? Man, why didn't you get me when I was way over there? You trying to trick me? You was making me run. Anybody else? Okay. Let's see. Which one? Hurry. Hurry, hurry. We got to do it fast because we don't want to run out of time. Let's see. Which one? All right. Now, the next thing I want you to inspect. With one hand, you may do so now. With one hand, pick up one wire. Hold it by the fat end. Yeah, hold it by the fat end. Which one did you have? Quickly, I want you to teach yourself how to open that by squeezing it. If you look at that really closely, it's got little teeth inside of it. Looks like an alligator. These are called alligator clips. Once you have inspected the first wire, once you have inspected this one end of the wire, you want to take the other end and inspect it the same way. Make sure it opens and closes. Once you make sure that wire opens and closes on both ends, drop it, let it go, get it out of your hand. It's no longer yours, it's mine again. Pick up your second wire. Not the same wire, but the other wire, and inspect it like you did the first wire. Squeeze it on one end and make sure it opens, then turn it to the other end and squeeze it. Make sure it opens. Good. Now, once you've inspected both of your wires, go hands free. Now, you may do so now. I want you to pick up one of your light bulbs. I want you to pick it up by the glass part with the silver part facing the ceiling. Here's what I want you to look for. Look for this little hump. Now, I don't know the scientific name for that. I just call it a little hump. Make sure that your light bulbs, all three of your light bulbs, have that little hump. You may do so now. Check all three of your light bulbs. Once you've checked your light bulbs and they all three have the hump, you may place them back on your table. Let me tell you something about these light bulbs. They are very, very sensitive. When I ask you to screw one in, I want you to screw it in gently. When it stops turning, you stop turning. If you don't stop turning, you will destroy your little hump. Your little hump will actually go inside the light bulb and your experiments will not work. Okay? Now, the first circuit that we're going to build is called a simple circuit. A simple circuit. Let's set up for the simple circuit and then I'll give you the definition for it. I want you to, and you may do so now, pick up one wire, open it and connect it to one of your battery terminals. Doesn't matter which wire, it doesn't matter which terminal. Once you've connected it to the terminal, let it go, drop it, get it out of your hand. It's no longer yours, it's mine again. Pick up your second wire, the other wire, and open it and connect it to the other battery terminal. You should have two different wires connected to your battery. Now what I'd like you to do is inspect your neighbor's battery. Make sure that your neighbor has two different wires on his battery. If your neighbor has the same wire, let me know because he's trying to blow up my laboratory. Oh! No, they're the same color, but they're different wires, right? Okay. I think it's right. All right. Now, here's how I remember the definition of a simple circuit. 1, 1, 1. Because if somebody were to ask me, hey, Dr. Shock, what's the definition of a simple circuit? I would tell them, a simple circuit is a circuit having one source, one path, and one load. Okay? When I ask you to do so, I want you to connect one of your wires to the empty screw here, and the other wire to the empty screw here. Not yet! Got to have your hypothesis. What do you think is going to happen? Yes?
Turn on.
You think the light will come on? What do you think?
Yeah, I think the light is going to turn on.
Turn on?
It's not going to turn on because none of the batteries, none of the light bulbs are.
You are correct. He said it's not going to turn on because we don't have a light bulb in. Now, before you make your connection, I want you to insert one light bulb in the socket closest to you. Do so now. No, not your wires, your light bulb. Connect one light bulb into the socket closest to you. Closest to you. That's furthest away from you. I want you to, if your battery is far away from your circuit board, pull it close because I don't want you to stretch the wires too much. Okay? All right, now give me your hypothesis. What do you think is going to happen? Yes?
Now I think it will turn on.
Now you think it'll come on? Yes?
I think that when you put these on there, the light bulb.
Well, you got to use think of everything that possibly could happen. Well, see your light's coming on. You're going to be an observer. What about, will it be bright? Will it be dim? Will it flicker?
It'll be bright.
Bright?
You don't have the whole thing on it, it might flicker.
Okay.
Since it's a big battery and only one light bulb, I think that it will be pretty bright.
Pretty bright, yes. May flicker.
May turn on and off somewhat.
Okay, one more.
It'll be dim.
Think it'll be dim. Okay, I have your hypothesis. Please make your connections now. Don't stretch your wires. Bring your battery closer or bring your circuit board closer. There you go. Let there be light. What happened here? I'm going to have to work with your, there it is. There you go. All right? You have just built a simple circuit. Disconnect the wires from your circuit board. Leave them connected to your battery. Disconnect the wires from your circuit board. Leave them connected to your battery. Now, the next circuit that we're going to build is called a series circuit. Now, I remember a simple circuit as 1, 1, 1. I remember a series circuit as 1, 1 more. Because if somebody were to ask me, hey, Dr. Shock, what's the definition of a series circuit? I would tell them, a series circuit is a circuit having one source, one path, and more than one load. Got a lot of information I'm going to give you now. So when I say please do so now, I want you to add your other 2 light bulbs. And then I want you to add a wire arm here with wire screws and a wire arm here with wire screws. Look at there. We made an S or a number 5. However your scientific imagination sees it. My scientific imagination sees that as an S because an S stands for science. S stands for series. S stands for shock. S stands for super students. And an S also stands for a tongue twister that I made especially for this particular circuit. And it goes like this. Shock says a series circuit shares a source. 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 I did it 4 times fast, and I bet you can't even do it 1. Try it.
Shock says a series circuit.
Wait, somebody call me Sock. Who called me Sock? That's all right. I will find out who it was. Okay, guys, got a lot of work now. You want to add 2 light bulbs? Then you want to add your wire arm here with wire screws and wire arm here with wire screws. Please do so now. Make an S or make a number 5.
Let's see this is.
If you're with me, say I'm with you, Doc.
I'm with you, Doc.
If you're ready to rock, say let's rock, Shock.
Let's rock, Shock.
If you need some time, cause you're behind, say, hey, wait for me.
Hey, wait for me.
Wow, that many people?
Never mind, don't wait for me.
Don't wait for you. How come? We gotta wait for you. We gotta keep moving, and we gotta keep moving together. Everybody ready?
Yeah.
Da, na, na, na. You ready to rock? You ready to rock with Dr. Shock? You need to put an arm with another one here. Make your board look like my board. Ready to rock? 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 Okay. Let's give them a couple seconds to finish that up right quick. When I ask you to do so, I want you to connect one of your wires to the empty screw here and the other wire to the empty screw here. Give me 2 hypotheses. What do you think is going to happen? Yes?
I didn't give it a flicker because it's more.
Flicker. What do you think is going to happen?
I think it's not gonna flicker because the electricity, like, there's gonna be a path and it's gonna go through.
Okay.
On the S.
All right. Please make your connections now. Oh, they're dim, aren't they? What do you think will happen if you unscrew your middle light bulb? What do you think will happen?
It'll all turn off because a series, because
You just got a loose connection somewhere, and I believe it's right there.
I know for a fact that a series circuit, if you unscrew one bulb on the other screw.
You're right. Unscrew one light bulb halfway. You're loose here too. And tell me what happens.
They turn off.
Ah, they all went off. Screw that bulb back in. Disconnect the wires from your circuit board. Leave them connected to your battery, and let's talk about what just happened. You guys noticed that all of those were dim, weren't they?
Yeah.
Now I know that's a 6-volt battery. Disconnect. All lights should be off. All hands should be free. All eyeballs should be right here on me. You ready for the next one? Disconnect. All right. Now, yes.
I know why all of the lights went off when you took one out.
Tell me why.
Because the energy wasn't flowing to the other one when you took the middle one out or another one out.
You're right. The energy stopped flowing. But why did it stop flowing? And that would also tell us why it was dim. Yes.
Because the path was disconnected.
The path was disconnected. That's true.
think because doesn't a series circuit has to have a constant flow of energy?
Yes, it does. Good. But think about the tongue twister. Shock says a series circuit shares. They're sharing. So that's a 6-volt battery. I know those are 6-volt light bulbs. So if they're all were 6 volts and they were, if a battery was 6 volts and the lights were 6 volts and they were dim, how many volts would they get?
Each one would have 3 volts.
No,
No,
you're close. 2 volts. Why do you say 2?
2 times 3 equals 6.
Not that. You're close.
6 divided by 3 equals 2.
6 divided by 3. See, I couldn't take the 6 times because that's adding more to it. Okay? When you divide it, that means you're sharing it. Okay? Let me disconnect and then tell you about the next circuit that we're going to build. The next circuit that we're going to build is called a parallel circuit. A parallel circuit. I remember a simple circuit as 1, 1, 1. I remember a series circuit as 1, 1 more. I remember a parallel circuit as 1 more. Because if somebody were to ask me, hey, Dr. Shock, what's the definition of a parallel circuit? I would tell them, a parallel circuit is a circuit having one source, more than one path, more than one load. When I ask you to do so, I want you to add your other wire arm here with wire screws and your final wire arm here with wire screws. Make an 8 or make 2 rectangles, however your scientific imagination sees that. Please do so now. You can unscrew your middle ones about halfway and take that hook and hook it in there. It'll save a little time. Good job. You want to add everything else you got. Make your board look like my board. Way to go, man. You're working out. Good. Yours did work last time, didn't it? Okay, good. Finish. You got to put your here. Make sure that's all the way in. And you put your other one there. If you're with me, say I'm with you, Doc.
I'm with you, Doc.
If you're ready to rock, say let's rock, Shock.
Rock, Shock.
If you need some time, cause you're slightly behind, say, hey, wait for me.
Hey, wait for me.
Are you ready?
Yes.
All right. In this circuit here, there are several different ways you can make this connection work. I'm going to show you all of those ways you can make that connection work. Then I'm going to tell you exactly where I want you to make your connection, because when we do this demonstration here, we're going to leave the light bulbs on a little while longer, and we got to move fast because I don't want them to get the bulbs to get hot and burn your fingers. Okay, I have to put that one on and tighten it down. All right. When I say please do so now, you could make your connection here and here, or here and here, or here and here, or here and here, or here and here. Or, no more ors. But where I want you to make your connection, when I say please do so now, is here and here. And it's just going to be right there on the sides. You want to connect, go hands free, because we're, like I said, these bulbs are going to be on a little bit tighter. But before we do that, I need your hypothesis. What's going to happen? Yes?
They're all going to be, no, I don't think they're all going to be dim. I think some of them are going to be bright, and then they're going to start getting dimmer as you go down.
Okay. Interesting, yes.
I think they're going to be light.
Think they're going to be bright?
I think they're going to kind of flicker.
Flicker? All right.
I think the attachment to these, I think the electricity will flow through and give them light.
Okay. Yes. You think they're going to flicker?
I think they're going to flicker.
Think they're going to flicker?
I think they're going to be dim.
Dim. All right, I have your hypothesis. Please make your connections now. Make your connections and go hands-free. All right. What do you think will happen? What do you think will happen if you unscrewed your center light bulb? Talk to me. Yes.
I think it might stay on.
You think it'll stay on? What do you think? Same thing?
It'll stay on.
All right. Everybody say they're going to stay on. Let's check. Please unscrew your center light bulb all the way out and put it on the table. Turn it the other way. There you go. All the way out on the table. Here's a trick question. I want you to leave that light bulb all the way out and lay it on the table. I want to ask you a question. What do you think will happen if you unscrew the light bulb closest to the wires? Yes. Think they'll go out? Think they'll stay on?
I think they'll stay on.
Think they'll stay on?
I think they'll stay on.
All right. Disconnect the wire or unscrew the light bulb closest to your wires.
Oh.
Stayed on, didn't it? All right. Take it all the way out, lay it on your table. All the way out, lay it on your table. Go ahead and unscrew your final light bulb. Leave the wires connected to your circuit board. Unscrew your final light bulb. You may do so now. Lay it on the table. All 3 light bulbs should be off. All wires should still be connected. All hands should be free. All head and eyes should be on me. Every second that passes by, 6 more volts worth of electricity is going towards your circuit board. 6 more volts that's not being used. So it's building and building and building. And I wanted it to build for a little while because I got a very important question I'd like to ask you. And the question is this. Do you trust me? If you trust me, and only if you trust me, I want you to put your hand in one of the sockets. Take your pinky, put it in the socket. If you trust me, do so now. What happened?
Nothing.
Nothing. Absolutely nothing. Because that's just a 6-volt battery. 6 volts worth of electricity is not enough to hurt you. I would have loved to see what happened if we were using more. Now, this next part is a competition. So, to make this competition fair and equal to everyone, I want you to interlock your fingers, put your hands on your head, and receive these final instructions. When I say go, I want you to disconnect the wires from your circuit board, disconnect the wires from your battery. Put your circuit board in the bag, put the wires in the bag, very carefully put your bulbs in the bag. If your battery had a cap on it, you want to restore the cap and then stand up. Do not stand up before you're done. Your time starts in 3, 2, 1, go! Disconnect the wires from your circuit board. Disconnect the wires from your battery. Put your board in the bag. Put the battery on the table with the cap on it. Wires in the bag. Bulbs in the bag. After you finish, stand up. Do not stand up before you're done. Your time is over in 3, 2, 1. Freeze. Freeze. Freeze like cheese. You're still sitting down. I got 1 person sitting down. Good. 2 people sitting down. You remain seated and continue to work. Everybody that's standing up just volunteered to answer a series of review questions. Here's how it goes. When I look at you, point at you, or tap you on your shoulder, this question is yours and yours alone. You will have a very, very, very short time to answer this question. If you run out of time, I will say time. If you give me an incorrect answer, I will say no, and you will remain standing. If you give me a correct answer, you may automatically take your seats. Are we ready?
Yes.
All right. When you came into my laboratory today, I told you that there are 4 things that any circuit in the entire universe needs. Name 1.
Load.
Load, correct?
Path.
Path, correct? Time. Time.
Circuit.
No.
Return.
Return, correct? Time.
Source.
Source, you are correct. 1 more.
Return.
We said return.
Path.
Path, yeah, sit on down. All right. We built 3 different kinds of circuits today. 3 circuits. We built 3 circuits. Name one. Parallel, correct? Series, correct? Time.
Simple.
Simple, simple. All right, both you guys sit down. And, oh, we got 2 guys standing, 3 guys standing, and all these girls, 4, 5, okay. You, come forth. What is your name?
Jacob.
Jacob. Jacob, I want you to remain facing this way. I'm going to ask you a question, Jacob. I'm going to walk away, but you continue to face this way. Jacob, if you get this question correct, all the boys can sit down and all the girls got to stand. You get it incorrect, Jacob, all the boys got to stand and the girls can sit down. Jacob, I'm a boy. Don't let me down. If you let me down, Jacob, I'm going to be all in your grill, baby. Jacob, when you came into my laboratory, I described to you that there was an 8-foot-tall clear capsule. There was a 7-foot-tall man inside that capsule floating in a liquid called formaldehyde. He's been there since 1895. Jacob, what was his name?
Herman?
Herman? He said Herman. Correct! All the boys sit down, all the girls stand up. All right. How do I remember the definition of a simple circuit? Time. 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 All girls supposed to be standing, yes. Time. Oh, you trying to trick me? How do I remember the definition of a simple circuit? Yes.
It's 1, 1, 1.
You are 1, 1, what?
It's 1, 1, 1.
1, 1, 1. Yeah. You were right if you said 1, 1, 1. Did you say 1, 1, 1 or 1, 1 more?
It's 1, 1, 1 at first.
Okay, at first you said 1, 1, 1. That's what I thought. You may sit down. Okay, I remember one. You come forth. It is up to you now to redeem the ladies. And what is your name?
Jakia.
Jakia. Beautiful name. I'm going to give you the same option I gave Jacob. Get it correct, all the girls can sit and all the boys can stand. Get it incorrect, all the girls that's even sitting down now got to stand back up. And you know what? You'll probably eat lunch alone because they'll be mad at you. No, they won't. I'm just kidding. Are you ready? I'm going to give you a relatively easy question. Don't let me down. Jalea? You said Jalea, right? Jakia. Where are we?
In the circles lab.
You're in my lab. Correct! We're just about out of time. So what I want you guys to do, everybody take your seat. Take your seat. Got to get you back on the bus. We got to return to the classroom.